Hello everyone. In our previous video we have studied about the formation and the development of male gametophyte. In this video let's study about the female reproductive unit of the flower and the formation of the female gametophyte. So the female reproductive unit of the flower is called as the gynoecium. It consists of pistil. The pistil are of two types, monocarpillary and multicarpillary. If there is a single pistil, it is called as monocarpillary. If there are many pistils, it is called as the multicarpillary. Multicarpillary is further divided into two, that is the apocarpus and syncarpus. If there are many pistils, if these pistils are free, it is called as apocarpus. If the many pistils are fused together, it is called as syncarpus. This is the structure of the female reproductive unit of the flower. It consists of three distinct regions: stigma, style and the ovary. The stigma is the topmost part of the female reproductive unit, where it consists of the sticky substance to which the pollen grains get attached. Below the stigma we have style. Style is the slender tube-like structure through which the pollen tube passes and reaches the ovary. Below the style we have the bulged structure, which is called as the ovary. The ovary is attached to the thalamus. Inside the ovary we have the ovule, that is the ovule is called as the Megasporangium. Now this ovule is attached to the ovary with the help of a tissue called as the placenta. In the next section let's study about the Megasporangium, that is ovule. Let's study the typical structure of the anatropous ovule. 80% of the angiosperms consist of the anatropous ovule, which is the inverted ovule. It consists of two distinct parts. One is the stalk, the other one is the body. The stalk is called as the funicle, and the funicle consists of two distinct parts. One is called as the raphe, the other one is called as the hilum. The funicle extends over the body of the ovule, and this area is called as the raphe. The funicle attaches to the body with the help of the hilum. The ovule is being covered by two layers of integuments, and since there are two layers of integument, we call it as bitegmic. In angiosperms we have two integuments, whereas in gymnosperm there is only one integument, and hence it is called as unitegmic. And the integuments arise from a particular region which is called as a chalaza, and this is for our convenience, let's label it as C. There is a region where the integuments are absent, and this region is called as the micropyle. This is the opening of the ovule through which the pollen tube reaches the ovule. Inside the integument we have a dense mass of diploid tissue, and this diploid tissue is called as the nucleus. So, in the typical structure of the ovule, we have a funicle, and the funicle is attached to the body, and the extension of the tunicle over the body is called as the raphe, and the attachment of the funicle to the body is called as the hilum. And this ovule is being covered by two layers of integuments, and hence it is bitegmic. Inside the integument we have the dense mass of tissue, diploid tissue, and these tissues are called as the nucleus. And these integuments arise from the chalaza, and below the integument there is an opening which is called as the micropyle. In the next section let's see the different types of ovules. Let's study about the types of ovule. The classification of the ovule is mainly based on the arrangement of three distinct parts of the ovule. They are the funicle, the chalaza and the micropyle. Let's classify the ovules based on this. So the first one is called as the orthotrophous ovule. In the orthotrophous ovule, the funicle, the chalaza and the micropyle are on the same lane, and it is on the straight line. It is called as the upright ovule. The second type of the ovule is called as the anatrophous ovule. In the anatrophous ovule, the funicle, chalaza and micropyle are not on the same plane, whereas chalaza and micropyle are straight. And this anatrophous ovule is otherwise called as the inverted ovule. And the third type is called as the hemitrophous ovule, where we have the funicle here, micropyle and chalaza. Micropyle and chalaza are on the straight line, and these are at the right angle to that of the funicle. The fourth type is called as the camelotrophous ovule, where we have the funicle here, we have chalaza and the micropyle. It is a type of ovule which comes in between the anatropous and the hemitropous. It is neither inverted nor it is at the right angle. It is at the angular position, hence we call it as the angular ovule. The fifth type of the ovule is called as the amphitropous ovule. The amphitropous ovule is very similar to that of the chymalotrophous ovule, whereas the only difference here is the embryo sac which is present inside is not spindle shaped as seen in the chymalotrophous. Instead, it is in the form of horseshoe shape. It is bent. And the sixth and the final type of the ovule is called as the cystinotrophous ovule, where the funicle takes 360-degree turn. It takes 360-degree turn to give rise to the chalaza and the micropyle, and this is called as the 360-degree ovule. So we have seen 6 types of ovule. The orthotrophous ovule is called as the upright ovule because the funicle, chalaza and micropyle are on the straight plane, and the anatrophous ovule is called as the inverted ovule because the funicle, chalaza and the micropyle are not on the straight plane. Only the chalaza and micropyle are on the straight plane. The third type is the hemitropous ovule, where chalaza and micropyle are at the right angle to that of the funicle. In chymalotrophous ovule, which is in between the anatrophous ovule and the hemitropous ovule, it is neither inverted nor it is at 90-degree. And it is angular position, hence it is called as the angular ovule. In the amphitropous ovule, we have the funicle here, the chalaza and the micropyle, which is very similar to that of the chymalotrophous ovule, but the only difference here is the embryo, which is the horseshoe shape. The next and the final type of the ovule is the cystinotrophous ovule. In the cystinotrophous ovule, the funicle takes a long distance of 360-degree turn and it gives rise to the chalaza and the micropyle. In this video, we have studied about the female reproductive unit of the flower, the typical structure of Megasporangium and different types of ovules. In the next video, let's study about the formation of the female gametophyte. Until then, happy learning from Edge to all.